In this video, we'll give a demonstration showing how Bpfilter works and how it works with the Netronome CX SmartNIC card on BPF offload. Bpfilter intercepts IP table commands and creates a BPF program to carry out the same functionality. This can give increased performance. So, just to begin with, let's load the Bpfilter module. So, the Bpfilter module is currently a prototype, and it can be obtained from the mailing list from the kernel netdev. Once it's applied to the kernel tree and the kernel is compiled, it will create a module within the net Bpfilter folder. To load the module, you just run it like an executable. So to show some statistics of what's currently happening in the system, let's run htop to show the CPU load, and let's run statwatch. Statwatch is a script we have within our upstream GitHub repository driver. And what it does is it shows eFTOOL statistics for the interface ENS4. So you run this here, we can see traffic coming in. So the host is currently managing around 8.6 million packets per second, and most of its cores, 8 of its cores, are currently being used at 100%. So let's say we want to actually drop the traffic coming in. Well, we would create an Iptables rules normally. So we run an Iptables rule that filters the incoming traffic on ENS4, and let's say we want to block the IP address 10.0.0.4. Now, what happens? Firstly, we have an offloaded message from Bpfilter, and we can see that all the CPU cores are back to 0%, and the reason this is that none of the traffic is being passed up to the host. This is the host traffic here, and we can see it's all 0. And the reason is that the BPF program is run on the actual network card here. So we can see 59 million packets per second come in off the fiber link, and they get stopped actually at the network card, so they never actually reach the PCIe rings or queues. So how does this work? If we type in the IP command, ipclink, we can see for ENS4 we have a BPF program on offload. If we use Bpftool, we can see we've got one program loaded onto the card. So how does the program work? Well, we can actually dump the program using Bpftool. So we can see here what's actually happening. The packet comes in and it actually has translated the IP table rules to this here function, where it checks the IP address to see does it equal 10.0.0.4, and if so, it drops the packet. Now, why is this so good? Firstly, CPU usage is down to 0, which is great. The processor is actually still able to actually do processing, and it's not just trying to cope with the network traffic. Secondly, we're actually more efficient than the CPU. The network card is a lot more power efficient at actually handling the traffic, so we're saving energy for the customer. And we're also handling a lot more packets. 59 million packets per second is much more than what any form of CPU can handle, especially due to the ×8 PCIe bus. So with Bpfilter, we have a lot better functionality. Now, Bpfilter is still in the prototype stage. It is not a commercially available product just yet, and it's not stable. But it is a taster of what might be to come in the next couple of months as this here functionality improves and actually the actual API actually improves.